Hello, everyone. I'm Andy from ThinkMo. I am currently teaching CCIE courses. From today on, I'm going to share with you CCNA, CCNP, CCIE related technologies. Today's topic is what is a data frame. First, we need to look at the data. Why are we talking about data? In today's internet, every household has a network. Then we have to find out, how is data forwarded on a physical line? So what exactly is a data frame? In the picture below, hosts A and B need to communicate with each other. It's transmitting data to each other. These computers can only recognize bit streams or a pulse. So what's the relationship between them? The first is that for the host you are byte. Byte is just some number in binary. It's either 0 or 1. These network devices recognize characters. These characters are then combined and sent to the peer end in sequence. Let's put it together again. So how do you get the data frame? It's put together by byte. It becomes bytes. The multiple bytes are then combined. It's going to be a data frame. Let's talk about the relationship between byte and bytes. 8 bytes equals 1 byte. Byte is the word you use to write an article. Bytes can be thought of as words. Then the bytes are combined in turn. So there's some punctuation in the middle of byte. Beautify the whole. After beautifying is equivalent to frame. When you combine it into a data frame, it can be transmitted over a physical link. So let's look at the format of the data frame. There are two most common types of it. One is Ethernet 2. One is IEEE 802.3. About the difference between them, it can be mentioned briefly here. You can look at the frame format. So why is it now called Ethernet? Because it's all TCP/IP now. Including the early IPX are now obsolete. So I don't pay too much attention to it. Ethernet Frame 2 contains the source MAC address and destination MAC address. In a later video, we'll talk more about the differences between Ethernet 2 and 802.3, whether it's from the frame format or anything else. Next is the type. Type refers to what protocol is used by the upper layer. In the middle is the field data section. FCS is frame tail. I just talked about that. Words made up of characters. If it doesn't fit, it should be embellished. Equivalent to repackaging. There's a lot more to combine into frames. If you want the device to recognize, something has to be encapsulated. Next is the data frame of 802.3. The first is the source MAC address and the destination MAC address. In the middle is the type length value. Then LSAS, snap data, and FCS. The format of IEEE 802.3 is obvious. Slightly more than Ethernet 2. And then what does the data frame do? It must be encapsulated before being propagated over the Ethernet physical medium. Let's say you buy something expensive on Taobao. The seller will package it during delivery. So in the format of the data frame, data is encapsulated before and after the data section. Of course, this information includes the preceding destination MAC address and original MAC address. This is the equivalent of package delivery. Data information filled in. And then type refers to who should go next. So the information encapsulated in the data frame determines how data is transferred. How and where. Each of these fields is useful. Data frames transmitted over Ethernet come in two formats. This is Ethernet 2 and IEEE 802.3. The choice of format is determined by the network layer in the TCP/IP protocol cluster. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message or send me a private message. If you're interested in what I'm talking about, Hope to like and subscribe more. Thank you. See you next time.